Okay, before we move over to multiplication and division, let us just focus on some of the representation of I or square root of -1. Recall that we said I is equal to square root of -1. And where did this come from? If somebody asks you, you're going to say that, hey, for example, if I ask to solve x squared plus 1 equal to 0, x squared is equal to -1. And if I take square root of both sides, it is square root of -1. Using a calculator, it gives us an error. It means that this guy is not a real number. Well, this came from solving this equation, and we saw that square root of -1 using a calculator is an error. What's the meaning of that? It means that it's not a real number. So we define complex numbers, but what do we stick to? We stick to I as square root of -1. So I expect you to ask, well, what if I have some numbers represented this way? Example. Question says, write the following in complex form. Okay. The very first number given to us is square root of -4. The second number is square root of -25. The third number is square root of -36. The fourth number is minus square root of -49. The fifth number is negative square root of -1. What are the representations of these? Well, let us begin by this guy. First of all, from algebra, remember that if you have the square root of A times B, you can separate this and write it as square root of A times square root of B. If you have multiplication between two numbers, you can separate the radicals. Just be careful. If it's addition or subtraction, we are not allowed to separate these. It only works when you have multiplication or division. So again, square root of A times B is square root of A times square root of B. Okay, so this is a -4. Why you're mentioning square root of AB? Well, -4 is -1 times 4. That's how I officially define -4. -4 is -1 times a positive number 4. So your A is -1, your B is 4. You can write it in separate form. -1 times square root of 4. Well, I already know that square root of -1 is nothing but I. So wherever I see square root of -1, I'm going to use its notation, which is I. And at the same time, square root of 4 is just 2. So I get I times 2 or 2I. There you go. Now what should I do with this guy? I have square root of -25. Well, you can officially write it as square root of -1 times positive number 25, then follow algebra and separate square root of -1 from square root of 25. But square root of 25 is nothing but 5. And square root of -1 is nothing but I. So I get I times 5 or 5 times I. What about square root of negative 36? This guy can be written as square root of negative 1 times 36 or square root of negative 1 times square root of 36, I times 6 or 6 times I. Perfect. What about this guy? Okay, just be careful here. We have a negative sign in the front of the radical. You have to copy this guy down. There is no way to get rid of this negative sign. You cannot just say that, hey, negative times negative is positive. It is wrong. So copy your negative sign. Inside the radical, you have negative 1 times 49. Copy down your negative sign. You get square root of negative 1 times square root of 49. You have negative I times 7. Negative I times 7 or negative 7I. Now you end up with negative complex number. What about this guy? Well, I already know this is I. So I get negative I. Very good. Another important thing that you should be careful about I is when you multiply I by itself a couple of times. What do I mean by that? So let's see. Suppose I give you this example. I just ask you, raise I to the following exponents. Okay, so the very first one says I to the second power. B, I to the third power. C, I to the fourth power. D, I to the fifth power. E, I to the sixth power. Very well. So what do we have here? We have I squared. I squared, I times I, it gives you negative 1. I squared is negative 1. Why is that? I is equal to square root of negative 1. If I raise both sides to the second power, I get I squared on the left and I get negative 1 on the right. What about I to the third? What's the meaning of I to the third? It means that I have to remember that if you have a to the nth power, it is a times a times a n times. All right. So when I ask you to raise I to the third power, you have I times I squared. But you already know I squared is negative 1. So this guy becomes I times negative 1 or negative I. Guys, memorize this. I squared is negative 1. In a question, in your homework, if you see I squared and you leave it as I squared, you're going to lose points. I squared is always negative 1. So if I raise I to the third power, it means that I have I times I squared, but I already know I squared is negative 1. So I end up with I, and I squared is negative 1. So the result is negative I. What about I to the fourth? Okay, this is interesting. It means that I have I to the second power times I to the second power. But I to the second power is negative 1. Also, I to the second power is negative 1. Negative times negative is positive 1. Well, it is now interesting. Now you have I to the fifth. I to the fifth is I to the 4th times I to the 1st power, or just I. But we just learned that I to the 4th is always 1. So this guy becomes 1 times I, or just I. What about I to the 6th? I to the 6th can be written as I times I to the 5th. I to the 5th, we just learned that I to the 5th is just I. So you need I times I, or I squared, which is going back to the loop, -1. You can try checking I to the 7th. I to the 7th is I times I to the 6th. I is I to the 6th is -1, and we got -I back. Guys, take a look at the pattern. So I to the 6th and I to the 2nd, they are the same thing, -1. I to the 7th and I to the 3rd are the same thing. So if I raise I to the 8th power, we expect that to be the same as I to the 4th, and so on.